So now we want to look at multiplying two or more rational expressions and also dividing rational expressions. And then we'll also go through addition and subtraction. So we'll go through the 4 basic arithmetic operations using the rational expressions. So a lot of this is just going to come from your normal fraction rules. So, for all of these, let's just start with a number and just quickly remember, hopefully you remember how to do stuff like this, right? If you're just multiplying two fractions, you multiply the numerators, you multiply the denominators, and you get 21 over 20 in this case. Okay, so you just multiply straight across on the top and bottom. Rational expressions are no different here. They might have an added step of like maybe we need to simplify at the end, but you can have that with numbers too, of course. Okay, so let's look at an example of x squared plus 4x minus 5 times, or divided by 3x plus 18 times 2x minus 1 over x plus 5. Okay, so same idea. You're just going to want to multiply across the top, x squared plus 4x minus 5 times 2x minus 1, and multiply across the bottom, 3x plus 18 times x plus 5. Now, depending on the context, there might be no need to actually multiply these out. Like we could just leave it like this. And in this context where we're just trying to like make things as simple as possible, this is kind of an extension of like simplifying rational expressions. We actually don't want to multiply it out. We want to instead factor everything and then see if there's any common factors that we can cancel out, because maybe we can make this a little bit simpler. Okay. So if we factor the top, and in this case, there are some things that we can see can be factored, like the x squared part. Sometimes maybe you don't have anything that can be factored, right? And then maybe you just multiply everything out or whatever. So let's go ahead and factor this first, though. So we have x squared plus 4x minus 5. That's going to be x plus 5, x minus 1. Okay, and then we still have the 2x minus 1 here. And now on the bottom, we can take a 3 out of the 3x plus 18. So we want to look for number factors too. This is only going to be x plus 6, so it's not going to cancel with anything though. But regardless, we can do it just in case there's something we can cancel out. So the only thing that cancels is this x plus 5. Okay, and I'm just looking just to make sure I don't see anything else that can factor. I want to make absolutely sure before we go ahead and multiply everything together now. Okay, so now that everything is canceled, now we can multiply it out. Okay, and again, depending on the context, maybe you won't want to multiply it out. Maybe you do. Whether or not you're quote unquote supposed to kind of just depends on like what the book you're following is. I don't really care either way, as long as it's unless the problem like specifies to multiply it out or something like that. But anyway, let's just go ahead and multiply this out. So we get 2x squared minus 2x minus x, so minus 3x plus 1. And then there's the 3x plus 18. Okay. So either way, if you want to leave it like the left-hand one, maybe rewrite it without the x plus 5s, or leave it like the right-hand one. It doesn't really matter either way. Okay, so let's do another example. So now we'll say x squared plus, oops, sorry, that's the same one. Here, x squared plus 11x plus 30 over x squared plus 5x plus 6 times x squared plus 7x plus 12 over x squared plus 8x plus 16. Okay. So it's a good idea when we have 4 quadratics here, right? Lots of things that we're going to need to factor. So it's a good idea just to do the factoring right away. Just like when you have like numbers being multiplied, like if you have like 4 times 3 over, or sorry, maybe I should say like 4/9 times 3/8, right? You kind of want to cancel out terms first before doing the multiplication, right? So kind of the same idea here. It's a good idea to cancel the terms out first. Okay. So go ahead and factor everything. So we get x plus 5, x plus 6 on the top, x plus 3, x plus 2. Okay. And then we have x plus 3, x plus 4, and x plus 4 over x plus 4, or times x plus 4. Okay. So we'll just go ahead and cancel out anything we see that can be canceled, right? And just, you don't even really need to rewrite this. Like, this is just kind of just combine them onto one line, right? No need to write that twice because we're just multiplying across here. So we have an x plus 3 on the top and bottom, x plus 4 on the top and bottom, and it looks like that's it. Okay. So ultimately we'll have x plus 5, x plus 5, x plus 6, divided by x plus 2, x plus 4. So again, you can leave it like that, or if you want to multiply it out, you got x squared plus 11x plus 30, which is actually just that first factor, right? That second one just completely canceled. And then x squared plus 6x plus 8. Okay. And that would be our final answer. Okay, so now let's turn our attention to division. So again, this is just like multiplying fractions. So let's do a quick review of that. If we have 2/3 divided by, I don't know, say 3/4. Remember, this is the same thing as multiplying by the reciprocal. Okay, so sometimes we might write it as like same, change, flip. Okay, so you leave the first one the same, change the division to multiplication, flip the second one, meaning you take the reciprocal of it. Remember, the reciprocal of a over b is b over a. Okay, so when we say the reciprocal, we just mean flip it over, right? The numerator becomes the denominator and vice versa. So here we'd have 2/3 times 4/3. So we just turn it into a multiplication problem. So we get 8/9. Okay. So no problems there. Sometimes it can be a little more confusing if you have it written like maybe 5 divided by 2/3 or something like this. Okay. This is the same concept. It's just, the division bar is just written in the same place. This a different place. This is just 5 divided by 2/3. So it's still going to be 5 times 3/2, which is going to be 15/2, right? Because we think of this as 5/1. So oftentimes the rational expressions will be written like this. So it's something to keep in mind. But you can just rewrite it like this, and then it's basically the same thing. Just whichever version you're more comfortable with is fine. So if we just go to some rational expressions now, let's do a simple one first. Let's say we just have 1 over x divided by x squared over 3. Okay, so nothing to worry about with like canceling or anything here. It's going to be 1 over x times 3 over x squared. Okay, so we flip the x squared over 3 to get 3 over x squared. So here we'll get 3 over x to the third then. Okay. Now, do another one here. 2x squared plus x minus 6 over x squared minus 1 divided by x squared minus 4 over x squared plus 2x plus 1. So again, if you want to, you could just go ahead and factor everything, before you do anything. It doesn't really matter what order you do it in here. You can't cancel things out until you, flip, so that you know what side is, the factors are on. So let's just go ahead and factor everything first here. So we got a bit of a tricky one. 2x squared plus x minus 6. Let's see. I'm doing these on the fly, so looks like that's going to be plus 2 minus 3. Let me check real quick. That looks right. And then x squared minus 1, that's the difference of two squares. So we have x plus 1, x minus 1. X plus 2, x minus 2. And then x plus 1, x plus 1. Okay. So now we can go ahead and do the multiply by the reciprocal. 2x minus 3, x plus 2, over x plus 1, x minus 1, times x plus 1, x minus 1, x plus 1, over x plus 2, x minus 2. Okay. So we just changed to multiplication and we flipped the second one. Okay. So go ahead and cancel the common factors here. We have an x plus 2 in common. We have an x plus 1 in common. That looks like everything. So we have 2x minus 3, x plus 1, over x minus 1, x minus 2. And you could leave it like that, or we could multiply this out to get 2x squared minus 3x plus 2x, so minus x minus 3, over x squared minus 3x plus 2. Okay. And then that would be it. No way to make that any simpler because we already saw there's no more common factors there.